Hey guys, it's me. I'm back. Surprise. Just kidding. It's not a surprise. I knew you were expecting me. So this is module 7 for chapter 3. It's over the movement of matter. So last time we did the movement of energy. This time we're doing the movement of matter. All right, so let's get going. By the way, this is kind of a long module, so I apologize if this is quite lengthy. So our master challenge, here it is. Ta-da! It is, we're going to be talking about biogeochemical cycles. So I want you guys to write down what you think biogeochemical means and what might be an example of one of these cycles. No peeking. Don't peek. Don't get tempted. Say no. Okay? Just write down what you think it is. And remember, I'm not looking to see if you're right or wrong. I just want to see what you know or what you think, okay? So that's it, all right? So do it. Okay, so this is our first cycle. There are like 5 cycles we're going to be talking about. This is our first one, the hydrologic cycle. What do you think this means? You've been learning about it since you were like real tiny, It's got another name. It's also known as the water cycle. What? All right. So the hydrologic cycle, that's what we call. That's like its science name. Okay. Remember hydro, water. That's the way I remember that. It's the hydrologic cycle because the hydro is water. Now, in this diagram here, you can see that there are quite a few different things going on, and we're going to talk about those real quick. I'm not going to spend a lot of time on this one because you guys should know the water cycle. All right. So what the 3 main things that you learn about when you learn about the water cycle are evaporation, condensation, precipitation. Okay, those are our 3 main things that we learn about and that we focus on when we teach you guys about the water cycle. But there's quite a bit more processes and steps within that. Okay, so we can see, I'm going to go ahead and circle. Here's evaporation. Here's precipitation, okay? And we don't have condensation written on here, but condensation would be right there where the clouds are, okay? That would be condensation. There's some other things on here like plant uptake. This is when, or you might know it as root uptake. That's when the plants get uptake. They bring up the water into them from the ground. Infiltration, it's kind of like I think about, when I think here infiltration, I think about like, you know, like those video games where you have to infiltrate the enemy army or something like that. Like that means, infiltration means that it's percolating, it's going through, it's getting through, in this case, the soil. And then you have surface runoff. That's when you have water, literally, it's not like running like we run, but it is running off into streams and rivers. This is going to be like when it rains. When you see like the water going down the side of the road, that's runoff, that's surface runoff. And then you have solar heating, which is the sun heating up the water. Now, some of the words on here that you need to know, one is called transpiration, and transpiration is going to be this right here. I'm going to like use a different color. We're going to go with blue. I'm going to use a different color. So this is transpiration. Transpiration is when you have evaporation taking place from trees, okay? So the way I remember that is the T from transpiration and the T with trees. That's how I remember it. It's from other plants as well, but T for trees, T for transpiration. Okay, so you need to make sure that you know those words. Now, how do we affect the hydrologic cycle? Well, we really do affect it. The Earth is a closed system, so what that means is that we don't, like, what we got is what we got. Like, we're not getting any more of it, and we're not going to get, we could have less of it, but not water, okay, because water is constantly going through the water cycle. So because of that, we can really affect it. One of the ways we can affect it is through harvesting trees. So you can see in this image here where I'm going to draw the arrow, this is Haiti. And this one, I'm going to use red. This is the Dominican Republic. Okay, they're all both on the same island, but you can see a very direct difference in these two countries. And the main reason is because Haiti has massive deforestation. And you guys should have hopefully read the opening article about Haiti and about their deforestation. So this is just a main example here. But one reason that this deforestation causes major issues is because, one, it limits or it lessens the amount of evapotranspiration, which is when we have, like, you know, transpiration happening where we have water evaporating from plants and trees. And it also reduces the plant biomass. So remember, biomass, that is the amount of living stuff that, or once living stuff, so that'd be like leaf litter and all that jazz that's on the bottom of the forest floor, okay? And that can cause issues as far as runoff and things like that. Another way that we affect the water cycle is when we go through and we change up how rivers and streams are functioning, or we make lakes. And that can cause there to be major issues as far as, you know, affecting the ecosystem, affecting other animals and plants that would rely on that. When we divert water for either a reservoir for drinking or irrigation for plants, or if we're using it for industry, that can cause major issues. So that's kind of how we impact the hydrologic cycle. All right, now the next one is the carbon cycle. So we remember, carbon is the letter C, or the element. It's represented by C on the periodic table. It's number 6, so that means it has 6 protons and 6 electrons. And carbon is, well, there's no nice way to put it. Carbon is basically like the thought of the periodic table. Like, carbon began with everybody. And, you know, thank goodness for it. Like, carbon's just making sacrifices, because without that, we would not have a lot of the things that we have, and we would not be here, because our bodies, while they are made up of a lot of water, they are also made up of a lot of carbon. So, the carbon cycle, this is a diagram of it. This is in your book, so you can look at it like in further detail there. But one thing I want you guys to notice also took place with the hydrologic cycle is that there's an atmosphere component here. So carbon's going into the atmosphere, water is going into the atmosphere. It's also happening in water. This is like the ocean over here. Bloop, bloop. Okay, that's like the ocean. And it's also happening within soil. Now we're going to go through the different processes in the carbon cycle right here. So because you guys might not be as familiar with the carbon cycle as you are with the hydrologic or water cycle. So in the carbon cycle, there are seven different processes that take place. And they can either be fast or slow. Now the ones that are fast, those are the ones that interact with biotic factors. And remember, biotic factors are living or once living things. And slow part is going to be abiotic factors, so things that are non-living. So in this case, it's going to be like rocks and soil and stuff like that. The air, okay? Excuse me. So these are the 7 different ones. Now, some of these go together, like photosynthesis and respiration. Those two go hand in hand together. And would that be a fast part or a slow part? That would be a fast part. That involves plants and other animals. So remember, plants are using carbon dioxide. So there's the carbon. They're using that when they are going through photosynthesis. And respiration, for us, we are respiring carbon back into the atmosphere. So these two things go together, and that with the living process. Now there are 3 other ones that go together, which is exchange, sedimentation, and burial. These take longer. These are slow processes. So exchange, sedimentation, and burial, this is when carbon gets buried within the ground or gets goes back into the soil, or also goes into the ocean, because carbon will actually come down from the atmosphere into the ocean, and you can see that on the previous slide, or if you're looking at your book while we're going through this, you can see it in the diagram in the book. These things take a while. Yes, there is carbon in the ocean, and that is part of the process. And then the last two here, extraction and combustion, they go together as well. And so extraction would be when we take it out of the ground, and combustion would be when we use it like in cars and stuff. So remember, carbon comes in many, many different forms. I told you it's like the thought of the periodic table. It gets everything. So because of that, carbon shows up in different ways. On the slide, you can see one of my personal favorite forms of carbon, which is diamonds. Diamonds, my birthstone, so I'm all about that life. But it is basically carbon. If you take carbon and it is exposed to enough pressure, then you will have real diamonds, not the cubic zirconium stuff. Okay. So this is another image of a type of carbon, which is coal. We also find it in our oil and things like that. So fossil fuels. Fossil fuels are carbon. Okay, guys, except for maybe natural gas, but they're all pretty much carbon. So, hold on, I gotta sneeze, I think. No? Okay, I'm good. All right, sorry. So the way that we impact the carbon cycle is huge. I'm not going to go into major detail here, but it is really big, because if this is one reason why we are constantly having the discussions and talking about climate change within the media and within politics and on between different countries, because of carbon. There's so much carbon dioxide and carbon just in general in the atmosphere. Carbon holds a lot of heat. It's like a great, nice, huge blanket, and that can cause the earth to heat up. Before the Industrial Revolution, everything was like going cool. It was in a nice balance, but then after the Industrial Revolution, we were putting way much more carbon into the atmosphere than it was going into any of the other processes with photosynthesis and respiration, or sedimentation, burial, and exchange. Those were taking a lot, especially the burial, sedimentation, exchange, that takes a very long time, whereas us just putting it up into the atmosphere, that does not take very long. But the combustion of fossil fuels, that is a major way that we've impacted the carbon cycle. We've kind of knocked things out of balance, which is not good. And then also tree harvesting. So back to the deforestation aspect, that can be a major issue, because what do the trees do? They take the carbon in and they go through photosynthesis, and when they go through photosynthesis, they respire oxygen, which we need. So the more trees we cut down, the less amount of carbon that is getting used, so we have more carbon out in the atmosphere. No bueno. Okay, no bueno. All right, the next one we're going to talk about is the nitrogen cycle. Now, I'm going to warn you guys, there is a lot of chemistry involved with the nitrogen cycle. So just roll with me here. I mean, yeah, we got this, okay? So this is the nitrogen cycle image. It is also in your book. And this one has, you can see, it has a lot of words on this. There are, I believe there are 5 main points to the nitrogen cycle. We're going to talk about all of those points, but you can see a lot of them on here. There's some vocabulary words from previous slide, like decomposer, or not previous slide, but previous PowerPoint. Decomposers, producers, consumers, all of that is very heavily involved in the nitrogen cycle. Now, one thing to remember is that when we talk about the nitrogen cycle, what makes up the majority of our atmosphere? Nitrogen. Nitrogen makes up the majority. It makes up about 71% of our atmosphere. That's a lot, okay? We are surrounded by nitrogen. You are surrounded by nitrogen right now, but we're not able to use that nitrogen, Okay, and the reason why is because nitrogen in that form, it's N2. So N2. I'm going to write it on here the best I can. N2. Okay, and when we have this N2, that means there are two ends, right? If we all remember our chemistry, so simple. Now, one thing that is unique about N2 is that it has a triple bond. So the way I think about bonds is that there are three types, right? I think I've gone over this with you, but I'm going to just humor me. We have single, double, and triple. Okay, those are the ones we're going to be concerned with. Now, the way I think about it is hand-holding, right? This would be like a single bond. It's very easy to break apart. It's very weak. We're still bonded, but not so much, okay? This, like a platonic handhold, this would be like a double bond. It's stronger than the single bond, but, you know, if I apply enough force, then it can still break apart, okay? Our final one is a triple bond, and the triple bond would be like this. Okay, this is our strongest bond. It is the hardest one to break apart. So, I could break it apart, but it's going to take a lot to break this apart compared to my other handholds or bonds. Okay, so we have single, double, triple. Well, nitrogen happens to have this kind of bond, the triple bond, okay, as N2. That's very difficult to break apart, and our bodies cannot break apart N2. We're not the only ones who can't do that. Plants cannot do it either. They are not able to break apart the two ends from each other. So that leads us to all of these different processes that we're going to talk about. So before we get to that, though, oops, I forgot about this. There are these things called macronutrients. These are the other ones that we're going to be talking about from here on out in this PowerPoint, which is nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. And these are nutrients that we all need a whole bunch to survive, okay? So, back to where we were with the chemistry stuff. Now, we need nitrogen. We need it a lot in our bodies. Nitrogen is a very important element because our bodies use it to form amino acids and nucleic acids. And those two acids, if you ever take biochemistry, you'll learn a lot about them. But they have to do with our DNA, RNA, and the proteins that are in our bodies. Now, because of this triple bond that N2 has, it's going to go through a lot of major chemical transformations. So we're going to go kind of slow through this so that we don't get confused. So the first one is nitrogen fixation. Okay, I like to think of it as the N2 is getting fixed so that producers can use it. Okay, it gets fixed to the point that producers can use it. So it goes through a process by decomposers to be able to be used by plants. Okay, so nitrogen fixation. It is nitrogen getting fixed so it can be used. The next process is nitrification. Okay, this is when, so a lot of times what ends up happening is when in nitrogen fixation, N2 is converted into NH4, which is ammonium. Okay, it's an ammonium ion, and you can see it right there, it's NH4. It gets converted into this. Now, ammonium is not, it's better than N2, but that's not necessarily what the plants can use. It's not what they prefer. So what ends up happening is in nitrification, ammonium goes through a chemical process of being transformed into nitrite and then into nitrate. Okay, so nitrite is NO2 minus. Nitrate is NO3 minus. So we're going from having some H's on the end to adding oxygens. And we start off with only adding 2 oxygens, and then we add one more, so we have 3 oxygens. So it goes from nitrogen fixation to nitrification. Okay. From there, we have assimilation. So assimilation, this is when the producers are using either the nitrate or the nitrite, and they are incorporating nitrogen into their tissues, so into their leaves, into their stems, okay, into their branches. They are incorporating nitrogen into their bodies, okay. Once that occurs, this is when we actually consume nitrogen, which was during assimilation. When we eat producers, we are actually consuming nitrogen. That's how we get our nitrogen, is through eating, not through breathing, because our bodies can't break that down. But our bodies can break apart NO2 and NO3. They can break that apart, because I believe that is just a double bond. We can break double bonds apart pretty well, okay? After that, organisms have consumed and assimilated nitrogen into their tissues, the next step is mineralization. It's also known as ammonification. Okay, so we have mineralization, or it can be called ammonification. And this is when decomposers come into play. And decomposers break down the organic material from dead bodies or from waste, okay, and they convert it back, convert this organic compound back into inorganic compounds. So this is basically when we have you can think about it as a dead body, and it is organic, okay, it's biotic, it was once living. Now we have decomposers come in, and they break it back down into like something that is abiotic, or like soil or nutrients, okay? So this is just decomposition. But in this case, it's mineralization and ammonification, because we are having nitrogen go from being in something that was once living, which is biotic, transforming that matter into organic compounds. And then the final one is denitrification. Okay, so denitrification. So it is like the opposite process of nitrification. So this is when you have nitrate being converted back into a gas. It's being converted back into nitrous oxide, which is N2O. Okay, and then eventually it gets broken back down into nitrogen, or N2. So we go from N2 to nitrogen fixation, N2 gets converted into well, NH4 in nitrification, which then transforms into NO2, and then which is nitrite, then into nitrate, which is NO3. Assimilation, the plants have assimilated this into their tissues. We then eat the plants. Nitrogen's in our body. Either when dead things happen, you know, dead bodies, or we have waste products like poo, okay? Those things go through mineralization, which is also known as ammonification, which gets broken back down from being biotic compounds to being abiotic, so turning kind of like into soil. And then from that part, we have denitrification, which is taking nitrate, which is in these tissues that have been broken down, and transforming it to nitrous oxide, which is NO2, which eventually becomes nitrogen gas, or N2. So it is a cycle, it is a circle. All right, so I know that's a lot. I know that may be kind of confusing, but it's very important for you to understand this. There have been AP questions about this, like a lot, okay? How do we impact the nitrogen cycle? Well, the first way is through leaching. Leaching is when you have nitrogen basically coming out of the soil or coming out of rocks. It leaches. This is when we have too much nitrogen. Nitrogen is kind of like steroids for plants. If you fertilize areas, then you are adding nitrogen to the system. And plants love nitrogen, especially if it's in an area where there's not a lot. But if you add too much nitrogen, then you get things like leaching, which is this image here is showing leaching. So we can have way too much nitrogen in a system, and that can cause all kinds of problems, which are touched on more in your book. Then the next cycle we're going to talk about is the phosphorus cycle. We have phosphorus cycle, and then there's one more cycle, or a few more we're going to talk about. So the phosphorus cycle is different from the other three cycles, hydrologic, carbon, and nitrogen, because the other three cycles, they all have an atmospheric component, but not phosphorus. Okay, phosphorus cycle is what we would call a sedimentary cycle. It happens mostly within the soil or water. It is not really getting into the atmosphere. The only way phosphorus goes into the atmosphere is if it's like atmospheric dust that has phosphorus part of it. But outside of that, it is not naturally in the atmosphere. So with the phosphorus cycle, again, phosphorus is very important to us. It is a huge part in DNA and RNA, and as well as ATP. If you've had biology, you should know about ATP. Phosphorus is the P in ATP. Okay. Usually phosphorus is found as phosphate, which you can see is PO4, 3-. That's how we normally find it in nature, is phosphate. Now, there are 5 different steps with this. We have assimilation and mineralization, which we just kind of talked about what those are. Assimilation is when it goes into your body. Mineralization is when something that is biotic is broken down and becomes abiotic. Those are both considered biotic processes because they start, assimilation I think is kind of obvious, but mineralization because it starts off biotic and becomes abiotic. Then we have sedimentation, geologic uplift, and weathering. These are all abiotic processes. And sedimentation, that's when we have it go into the soil. Geologic uplift, that's when it gets pushed up from the ground. And weathering, when rocks and different formations are broken down by different types of weathering, whether it's mechanical or chemical. So one of the major impacts that we have and that you may see or have seen from phosphorus is when we put way too much of it into ecosystems. And one of those ways that we do that is through household detergents. It's also in fertilizer, but it's mainly household detergents, and that's like soaps and stuff, have a lot of phosphorus in it. If we put too much phosphorus into something, it causes algae to grow like nobody's business, okay? It causes it to just explode, blow up. So what you end up getting is something called algae blooms. And in this picture here, you can see what an algae bloom looks like. A lot of times, depending on the algae, and most of the time it's going to be green. There are the rare occurrences where an algae bloom will be red. But what ends up happening is this algae grows and grows and grows in the water, and it ends up using all of the oxygen in the water. And that causes something called, okay, go with me on this. I think it's hypoxic. It becomes hypoxic. That's it, hypoxic. And hypoxic is when it has no more oxygen in the water. And it kills all of the fish. It kills everything in there. So algae blooms are bad. You do not want an algae bloom. They're going to kill everything. It's going to take over. It's done, okay? We also have seen how phosphorus has really started to alter plant communities. So in the Everglades, there is a lot of phosphorus that has been introduced into that ecosystem. And we're starting to see a lot more of certain plants than others because some plants react a lot better to phosphorus or a larger amount of phosphorus than others do, and that becomes an issue. Okay. Now these are other cycles. These cycles are important, but I'm just going to touch on them. We have the calcium, magnesium, potassium, and sulfur cycles. So calcium, magnesium, and potassium, they are all very important. You need all of these elements in your body, and you can see that potassium, it's the letter K, you can eat bananas and get potassium. Calcium comes from milk, so I got a little joke up there. And then the last one, magnesium, we can get that from a lot of other fruits and vegetables as well. So these are all, when they're dissolved, they become what we call cations, and cations are positively charged ions, so they have a positive charge, and they end up attracting negative charges. So it's like opposites attract. We have like positive and negative, and they end up attracting things that have negative charges, and that's usually in soil. And so a lot of their cycles and processes have to do with being in the soil and being absorbed by plants, and then we eat it, and it continues through that. It's similar to the phosphorus cycle, because there is no gaseous phase for any of these three. And then the last one is the sulfur cycle. So you can see the sulfur cycle, it is more like the first cycles we talked about, where it goes into the atmosphere. There is water involved, there is land, soil involved. But one thing I really want to point out to you guys is this acid precipitation. Okay, that's acid rain. We're going to talk a lot more about acid rain later on, but sulfur and actually nitrogen are a huge factor in acid precipitation or acid rain. Sulfur dioxide is the big no-no, and that usually comes from factories that cause this to occur. So because of this sulfur cycle, we ultimately, in our involvement, we ultimately end up with acid rain, which will not kill you, but it does damage property and is very bad for the environment. So that's our shabam on Module 7. It is pretty big, okay, for you to go through and read it, but this is very important. Normally in my regular class we take like a week or two on this, but we're moving through it pretty quickly because we're AP. So we have quick check here. There's 4 questions, and hopefully you can answer these. Use your book to help you if you need to. And email me or ask me any questions that you guys might have. This stuff will be on your test, so good luck.